Hi, um, this video is to correct very big mistake that I'm committing when um, at this moment where I'm presenting this series for you is that I'm writing wrong the way that the orthogonal vectors and parallel vectors are or describe it. The notation that I'm doing, this notation, um, here the idea was to represent orthogonal vectors, but I'm writing parallel, and actually I should write this way, um, A in parallel orthogonal with O, the unit vector, and this is 90 degrees. Um, and N is orthogonal or perpendicular to A. Um, A perpendicular or orthogonal, which is the same. A orthogonal with O, A orthogonal with N, and N. Let me write different. Just rearranging this. The unit vectors. A orthogonal with N or O orthogonal to. And parallel is when the vectors are this way on the space. And if the vectors were on arranged on this way, so then we will have this notation. This means parallel, and that means orthogonal or perpendicular. So this whole time, I'm probably doing this notation, and now I'm caressing. And if you are following the series, um, caress this, and sorry for that. And that's it. And gonna finish the video doing this again. And orthogonal to A, or we also could write A orthogonal to N orthogonal or perpendicular, which is the same, to O and A orthogonal or perpendicular to O. Okay, and they are unit vectors, and we have the module of a unit vector is equal 1, and when you measure the length of a vector, the process is this. We took you take the square root of the sum of the square of the terms, and when we eliminate the exponential, we are left with these followings. And this way we can write 6 uh, restriction equations because when we use this referential system, usually this way on the point on the end of an robot arm, let's say, and this is going to be what we call of an rigid body, and a rigid body, it has 6 degrees of freedom, and because this referential system is referenced to this other referential system, to the referential system XYZ. So this is going to generate 12 elements on a matrix like we were doing all this time, these 12 elements. And because of this, we write 6 equations of restriction for this rigid body that are moving around. And in order to solve problems, real problems, the idea is to let this rigid body, your position and orientation always known. So with all this information of these two, we can we can know the orientation and the position of this rigid body on the space, the way that it are moving all the time. We can have this control, and that's it. So sorry for this big error. So this notation is for parallel vectors, and this notation is for orthogonal or perpendicular, which is the same. Okay, that's it. Thank you.